Okay. So if we have a gambler, you see this gambler, he has $1. Okay, he will play indefinitely against the casino with infinity dollars. A fair game. What is a fair game? Fair game, you toss a coin. It's a fair game. So 50% of probability he will win, and 50% of probability fair coin. Okay, he will lose. The gambler wins or lose $1 on each play. He's certain to lose. Okay, so this is what the scenario if we put it in this scenario. Because if he have $1, if he lose, automatically he fall off the cliff. The game over, right? If he wins, and he still play. But he still has a probability to lose. Okay, but if this is a fair game, he will definitely lose. Everybody agree? I mean, to have an even chance. What is even chance? Even chance, that means this casino has infinity dollars, and this person has $1. If we really wanted the whole process to be 50%, this person will win and 50% casino wins, what winning probability should he have? 2/3, right? 2/3. That means if you go to the casino, you really want to have half chance to win. And if you play indefinitely, so the coin should not be fair when you toss the coin. And you should have at least 2/3 probability, because our money, okay, are limited. But the casino's money they have a lot of money. We are playing against, we have a limited amount of money. This one denotes the limited amount of money. But a casino has a larger amount of money. So the probability for us to fall off the cliff is much higher. Okay, so we must have 2/3 over here. So this is 2/3. So the probability, the P should be 2/3. 2/3 probability you will win each play. Then you are having half probability against the casino. Okay. So here, what if you say, oh, I have more than $1? Okay. Some of you say, oh, I'm rich, right? I have $100, not $1. Maybe my probability is higher. But is it? If you have $100, that means you started with $100. So this is actually equals to PI, 1 minus P over P and I. If P greater than 1/2, and if P less than or equals to 1/2. As long as the casino has infinite amount of money, if you have I dollar, doesn't matter. As long as the probability of each game is 1/2, you will definitely lose. You will lose all your money in the casino. So that's why most of the time when we go to the casino, if some of you went to Las Vegas before, right? Maybe you bring $1,000, or maybe you bring $10,000, or maybe some of you bring $1, or maybe $2, right? It doesn't matter. As long as the game is fair, you will definitely lose. Okay, you will lose all the money you bring to the Las Vegas. Is this surprising, right? You thought it's fair, but it's not fair. Okay. So this is random walk, yeah?
I have it. So if the amount of money is limited for the casino, how would that change? Like if the the drunken man has like, if he's further than 10 steps off the cliff, then he's safe. I'm just trying to think, how would that change our answer?
Okay, if the money you have is also infinity, then this will not be the same, okay? And then it's a fair game, right? But a casino always has a lot of money. Compared to what we have, it's often they have more than what we have, okay? Because every slot machine they are having, okay? They generate a lot of money every day, every poker table or any games. Okay. Unless you are a prince from Saudi Arabia. So you can have a casino then. You don't have to play. Now, you talked about one absorbing state. You said in that scenario we are talking about we have infinity, right? But now suppose we have two-person play against each other. I have $10, you have $20. Now obviously we have two absorbing states because either I lose or you lose, right? So then random walk, both of them are limited. Now let's see what's going to happen, okay? With two absorbing states. So this is a gambler ruins problem. It's a very well-known problem, gambler's ruin problem, a random walk with two absorbing states. Now we have two players. So player M has M unit of wealth, and player N has N units. So on each play, one player wins and the other loses 1 unit. So M wins with probability P, and N wins with probability Q. Okay. So if N wins, then M loses. So M plus P plus Q should equals to 1, right? So this is actually 1 minus P. Because when M wins, then N loses. Okay. They play until one is bankrupt. If we draw it right here, let me draw the let's draw it from player M's perspective. So M starts where? This is where M starts. With M units of money. And he has probability to gain money, that is P. He has probability to lose money is 1 minus P. And then he can go M plus N. So what happened here? If the M got M plus N, yeah, loses. The game over, right? So we're talking about they play until one is bankrupt. If you guys play with each other, you said the theory doesn't work. That's because maybe you play 10 times, you stopped. You have to play until one goes bankrupt. So this is absorbing. So M wins. Now we can go here, 0, 1, and 2. This is another absorbing state. M loses. Okay. So now the same, let's do the derivation. Let Pi denote the probability that starting with I, the gambler fortune will eventually reaches m plus n. So I equals to 0, 1, 2, to m plus n. So that's all the money we have, because m has m money, dollars. N has n dollars. So the total money we have is m plus n. And eventually it reaches m plus n. Okay? Okay, what's the probability of 0? If the person starts from 0, what's the probability he will eventually reaches m plus n? Because he has already bankrupt. There's no probability he will win. If he starts with 0 money, he has no money. Then how come he can win m plus n? So this is 0. What is a gambler starts with m plus n? 1 has already wins, right? He has already win. Now the problem is now we need to figure out what happened in the middle. What happened in the middle when we get started with pi? So pi obviously still a total probability rule. We can still go to the left or the right. What is the probability to go to the left? What's the probability to go to the right? Go to the right is probability pi plus 1. Because, and then plus 1 minus p and pi minus 1. And this is true for I equals to 1, 2 to m plus n minus 1. Because here, what does this denote? This denotes this person starts from I plus 1, then reaches m plus n. This denotes the person starts from I minus 1, then reaches m plus n. This person starts from I, and then reaches 1 plus n. So if starts from I, has a probability to go I plus 1, then what's the probability to reach m plus n from I plus 1? So giving the two possibilities, then you still reaches m plus n. So this is total probability rule. Now, obviously here, we need to write this equation in a way that we can iteratively solve this equation. Because we know P0, we know Pm plus n. We know this one and this one. Now we need to write this iteratively so that we can solve the problem. So this is P plus Q. Maybe let me write it this way. Pi plus Pi equals to Pi plus 1 plus Pi minus 1. Why? Because Q equals to, this is because Q equals to 1 minus P. And also this actually indicates that P plus Q equals to 1. Okay? Now let's derive this one. So let's move this to this side, and P together, Q together. Then this equation will become Pi plus 1 minus Pi equals to Q over P. This is actually Pi minus Pi minus 1. Therefore, if we write down this equation, this will become P2 minus P1 equals to Q over P. And then P1 minus P0. And this equals to Q over P, P1. What happened to this guy? The second one is P3 minus P2. This equals to Q over P, P2 minus P1. Note here, this is P2 minus P1. We have already got P2 minus P1. Okay, so this actually equals to Q over P, P1, and then we have a square here. We have 2Q over P. If we continue to do this, I minus P, I minus 1 equals to Q over P and Pi minus 1 minus Pi minus 2 equals to Q over P, I minus 1, and then P1. So what does this mean to us? Now we add this together. We have this group. We adding them together. We have Pi minus P1. You see here, why Pi minus P1? Because P2 cancelled, right? P3 cancelled. Pi minus 1, Pi minus 1 cancelled. So only left is Pi and Pi minus 1. Then you add all this together. So this will equals to P1 times Q over P plus Q over P square plus Q over P I minus 1. So then we can solve for Pi. Pi is a function of P1. Now can we solve for Pi? Obviously, how to calculate this one? How to get this one? This equals to what? P1 times what? Maybe let's check. Let me show you the geometric series. You remember what this is? What is this? This is geometric series, right? You see here, if you have AR square, if you put A equals to 1, you will have R square, R3 to R. Then you add n minus 1 together. This equals to this one, right? But we don't have A here. We don't have 1 here. We only add from this term, right? Okay. So, but we have another term in this side. You see this guy? This guy? If we move this guy to this side, it will become, if we get rid of this guy, this will become 1 plus. Agree? So this will equals to, so this term is actually, what did we get just now? 1 minus Rn divided by 1 minus R. And if you want to know why this equals to this, because if you put this equals to S, then you times R again, then you do the subtraction, you immediately solve the problem, you get S. Agree? So that's why this one equals to 1 minus Q over Pi divided by 1 minus Q over P. Okay? But obviously, what if Q over P equals to 1? So if Q over P equals to 1, then this is much simpler. Because everything here will become 1, right? Everything here will become 1. Because if you put P over Q equals to 1, this will give 0, this is 0. But if you don't solve that, if P over Q equals to 1, this is n. This is I. Oh, not n, right? So Pi is actually equals to 1 minus Q over P square. No, not square, I. Over 1 minus Q over P, and then P1. Or it could equals to I, P1. This is if q. My writing is terrible. Does not equal to 1 if q over p equals to 1. Okay. Now, what if p, because we know pm plus n equals to 1. Now let's put pm plus n inside. So let's solve this one. So we will have p1 equals to 1 minus q over p over 1 minus q over p m plus n if p does not equals to 1/2, and it will equals to 1 over m plus n if p equals to 1/2. And then what if we get a pm? Pm is actually equals to, we just replace this one because we have already solved for p1. Based on pm plus n equals to 1, we solve for p1 because we put this one as m plus n. This is m plus n, right? Then this equals to 1. Then p1 equals to, you just switch the order. So you got that first one. And second one is m plus n here. You got the second one. Now what happened to pm? Pm is actually, you just use this one times p1. You have already got a p1. So pm equals to 1 minus q over p m over 1 minus q over p m plus n. And m over m plus n. So if p does not equals to 1/2, if p equals to 1/2. Okay, so this is these are the final solution. If we start from m, okay, this is a real solution in the end. If we start from m, what's the probability to reach m plus n? Start from m. So in two cases, p equals to 1/2 or p does not equals to 1/2.